So I assume that you already have gone through the solution of this question using frame of reference train A, right? So we did it in two different approaches. One was the frame of reference as ground. Second was frame of reference as train A. And in this solution, we will focus on solving the question by choosing the frame of reference to be train B. Okay. Now, if you have not gone through these two solutions earlier, the earlier ones, I'll just give you a brief summary of what we have discussed so far in these two methods. Okay. So, what does frame of reference mean? It means okay, as we discussed in the previous solution, it means the camera angle, right? It means, if we were to compare things, the camera angle from which you observe the motion. So in relative motion, we always describe movement from the perspective of some observer, the camera angle. This observer defines the frame of reference, like we choose a camera angle. For example, if you are standing on the railway platform, the ground is your frame of reference. So if you observe two trains while you are standing on the ground, on the platform, your frame of reference is the ground. Whereas while you are inside a moving train, the train is your frame of reference. Okay. And we also did mention two types of frame of reference. While you are standing on a stationary frame, the frame of reference is inertial in nature. Whereas while you are in a moving platform, the frame of reference is non-inertial in nature, or inertial otherwise, non-accelerating frame of reference, and non-inertial or accelerating frame of reference, right? So these two, well, I have to be more precise here. While you are inside a moving train, you could be both inertial and non-inertial. If this moving train is in constant velocity, that becomes inertial. If the moving train is accelerating, then it becomes non-inertial. Well, I don't want to go into much of the depth for these two topics. The difference between inertial and non-inertial I have discussed in detail while we were talking about the solution based on train A as the frame of reference. Okay, so let us not go much into that. But what we will focus here is how to find a solution using train B as the reference. So when we have the observer's point of view from train B, we can say that we are using train B as the frame of reference, which means we are imagining that the passenger sitting in train B is our observer. From the passenger's point of view within train B is at rest. Any motion seen or measured is relative to this resting train B. Now this phrase, train B is at rest, resting train B. How do we assume, or how do we come to the conclusion that train B is at rest? To understand this, we need to spend some time in visualizing the given scenario. Now, the person, I assume, the observer here is on the platform. The observer here is on the platform, which means the frame of reference, in this scenario is the ground, right? So when the observer is on the platform, the frame of reference is the ground, which means every observation made with respect to the motion is with respect to ground. Let me write the one again. So every physical parameter which is mentioned with respect to the motion is with respect to ground. So displacement will be displacement of A with respect to ground, displacement of P with respect to ground, and correspondingly velocity of A would be with respect to ground and velocity of P would be with respect to ground, and therefore velocity of A with respect to ground is plus 25 meter per second, and velocity of B with respect to ground is minus 15 meter per second. Why plus and minus? Because we assume that towards right is positive and towards left is negative. Okay. Now, what is the difference between the previous and this visualization what we have here? So like I said, every observation that we make with respect to a motion depends upon the camera angle, depends upon the point where the observation is done, depends upon where the observer is standing. Where is the observer standing here? Exactly, the observer is standing in the or observer is standing inside the train A. So we have the frame of reference as train, not train A, it is train B, right? Now, velocity of A with respect to ground is 25 meter per second. Velocity of B with respect to ground is minus 15 meter per second. Now, this was the case when the observer was on the ground, was on the platform. Now, is he on the platform? No. The observer is now on train B. Is train B stationary? No, it is moving with some velocity, which is minus 15 meter per second, but not with respect to this observer. This is with respect to the ground. So, if we were to visualize velocity of train A from a moving train B, the velocity is actually expressed as velocity of A with respect to the observer. And where is the observer standing? He is standing on the train, which means velocity of A as seen by the observer. Let me just write it down here for you. So velocity of A as seen by the observer is equal to velocity of A as seen by the observer VAO, which actually is velocity of A relative to the observer, which is velocity of A minus velocity of observer. And since observer is standing on train B, this becomes velocity of A minus velocity of train B. Very important. This is the crux of discussion here, right? This gives you the concept, the explanation of the concept, the numerical explanation of the concept. Train B is at rest. How? Okay, right. So when the person visualizes train A from B, what he sees is velocity of A with respect to B, which is VAB equal to VAG minus VBG. VAG is 25, VBG is minus 15, so this becomes 25 minus 15, 40 meter per second. Now, what is velocity of B with respect to the observer? Velocity of B, let me just write it down there as well. So velocity of B with respect to the observer is actually the relative velocity of B with respect to observer. And since it is relative velocity, it is VB minus VO. Where is the observer standing? The observer is standing on the train B. So that becomes VB minus VB. And therefore, velocity of B with respect to B becomes velocity of B with respect to ground minus velocity of B with respect to ground, which is minus 15 minus minus 15, which gives us 0. Right? So, if I were to summarize this, velocity of B with respect to B is 0. Now, if we were to literally translate this, we could say that velocity of train B as seen from train B would be equal to 0. Now, when the velocity is 0 or is seen to be 0, it means that train B is apparently at what? At rest. Okay. Now, see, I think this explanation for for these two velocities that we have made. The reason why I'm going, I'm going so deep here is just to make sure that in future, if you're preparing for 2026 or the coming JEE or NEET exams, a possible assertion reason question or a statement 1, statement 2 types of question based on such scenarios, but not giving you the numerical values, is a possible case. And there, these kind of statements, these kind of concepts would be evaluated. Okay, so the target was to make sure that you are ready for those kind of questions. So please make sure you go through this explanation one more time. Write down this frame of reference as ground, frame of reference as train B, and then find out the individual velocities. Explain that to yourself, or maybe explain that, discuss that with your friends, and then make sure that you get the concept really clear. Okay, so yeah, so we were discussing about the sentence. From the passenger's point of view, train B is at rest. How? We discussed that in detail. Now let's see the rest of the part. So what happens, how is the motion visualized from the passenger's point of view? From the passenger's point of view, they are not moving. Even though the train is moving at 54 km/h to the left relative to the ground. Why? The person, the seat, the windows, everything around them is moving together at 54 km/h. Since everything inside the train is moving at the same speed and direction, there is no relative motion inside the train. So it was this sentence that I was trying to explain you numerically. So it feels like you are not moving. It feels like you are in a stationary room. To conclude, to the passenger, train B is at rest, and all other motion is described relative to train B. Alright? Now, what does the passenger see? Train A is moving at 90 km/h and train B is moving in the opposite direction at 54 km/h. But since we are sitting inside train B, we are not standing on the ground. We are observing everything from inside a moving train. From the passenger's point of view, train B is, this should be train A is coming towards them. Since both trains are moving in opposite directions, train A appears faster than it actually is. Why? Because velocity of A with respect to ground is 25 meters per second, but velocity of A with respect to B is 40 meters per second. So it is apparent speed. It appears to be at 40, whereas in ground frame of reference, it is only 25. Right? See, this is where the concepts become really important. This is where you'll be able to solve a question numerically very fast. But when the same question is asked in the form of assertion reasoning or any other statement-based question demanding your conceptual clarity, things become really difficult. Okay, so you have one question, one statement here, and the numerical part of this, and the explanation for this, or maybe the proof for this using a numerical equation, right? So please make sure that you pay attention to these things. Make a note of this, write it down, explain this to yourself. Now, relative velocity of A with respect to B. Train A is moving towards the right at 90, train B towards the left at 54. Now train B is the observer, so it says train A approaching from the front. So from the ground, train A is 90 kilometers rightwards, train B is minus 54 towards left. So VAB is equal to VA minus VB. VB is minus 54. Why? Because it is towards the left. VB is positive. Why? Because it's towards the right. So it is plus and minus. What we get is 144 km/h, or 25 minus 15, as we discussed earlier, that becomes 40 meters per second. So in other words, to the passenger inside train B, train A seems to approach at 144 km/h or 40 meters per second. Now, what will be the direction of displacement? Again, a possible question. Displacement of A with respect to B will be equal to velocity of A with respect to B into time. Now, time is absolute. It's not dependent upon the frame. So, Time is 8 seconds as given in the question because the observer is observing this for 8 seconds. Velocity of A with respect to B is 40 plus 40. So that becomes 40 into 8, 320. Now, direction is really important. From inside of the train B, train A seems to come from the left and pass to the right. Right? So it is maybe that's where we need the explanation, the visualization here. Yeah. So train B is coming from the left and it is moving towards the right of this train, train B. Now, since it is coming from the left and is moving towards the right, displacement, direction of displacement will be towards right, which is assumed to be positive. Okay, so direction of displacement would be in the positive direction, that is towards left. Or in other words, we can say that the relative motion is basically happening towards the left. Right? So now let's just compare these two methods that we've used so far. So this is train A and train B, and in both cases we need to understand both of these are inertial frames. Both of these are inertial frames. Right? The only difference that comes into picture here is the magnitude of relative velocity. While the observer was standing in train A, relative velocity was minus 40 meter per second, and therefore the net direction of movement was towards the left, which means displacement towards the left being negative. Whereas train B, when the observer was in train B, observing train A, the overall direction of relative velocity is plus 40 meter per second, plus being towards the right, and therefore direction of movement, the net direction of movement as seen by the observer would be towards right, and therefore displacement would be positive. And in both the cases, length of the train B, right? In both cases, length of train B, length is a scalar quantity which would demand the magnitude of this, giving the answer as 320 meters. Okay, now that was one question solved in 3 possible ways. So yes, so that's something that I wanted to explain you with respect to frame of reference. Now we will we'll do a very similar question, which again appears to be very subtle at the beginning. While you read it, you feel that the question is very simple. In fact, it is. But when you try to reframe the same question into a assertion reason or a statement 1, statement 2 type of questions, then things become difficult. Why? Because that question is based on the motion of a lift or motion of escalator, is again something which could be solved, which could be assessed in detail with respect to inertial and non-inertial frames. Okay, now let's move on to the question.